Thank you to Angel's Daisy, Beza Brooke, Coffee Milk, Crystal Embrace, Kamui Miracle, Lauren Hughes, Louise Savannah Price, and Taylor Haywood. You patrons are helping me pay rent this month, so thank you. So, I'm just gonna talk, and I hope that you find this rambling somewhat relaxing. So, I'm going to be talking about space and how cool I find it. There's a lot of things to go through, as it's infinite. So, yeah, there aren't enough topics to run out of. There are many, many topics that I have absolutely no idea about, but I'm happy to discover. But today I'm going to tell you a little bit about what I know in my kind of free time study. So, to begin with, if we look a little bit outside of our planet, we have the atmosphere, which is made up of a bunch of different types of spheres, stratosphere. I'm not going to pretend to know the rest. And then there's a lot of satellites and things, rotating Earth, lots of, phone networks and all of that. And then there's a big old bit of nothing for quite a long time. Like a long, long time. I think, if I remember off the top of my head, please do not quote me on any of these facts that I'm about to give you, because they are most likely highly inaccurate, but I'm doing my best from memory. Something along the lines of 36 Earths could fit between the Earth and the Moon, which a lot of people think is quite close. And, speaking in terms of space, it is really close, but a lot further away than people imagine, which I find quite entertaining. And we get to the moon. There's lots of little details about the moon that people like to say. We have, seas of tranquility and the other ones, which are large craters on the moon. I think there's only been 6 humans to ever walk on the moon. And my little tidbit is that Buzz Aldrin was actually meant to be the first man on the moon. But, oh wait. Yeah, I've forgotten what the name of the first guy. Armstrong. Yeah, Armstrong. Whatever his first name was. He was actually sitting a bit closer to the port at the time that they landed, and Buzz let him go first, which I thought was quite interesting, though, fact. And it is not made of cheese, unfortunately, because I could do with some nice mature cheddar right now. That would be really nice, just on some pasta. Anyway, yeah. And the moon is actually made up of a lot of different things. I cannot recall when, but not too long ago in terms of space-time, there was actually a collision. The moon is now made up of 2 satellites, I suppose you could say, a satellite being something that rotates Earth, or orbits Earth, I should say. So take 2 massive mounds of rock just kind of colliding into one each other and forming what we now know as the moon. And obviously, everything comes from stardust. That is a fact that I need to share. Okay, so the way that Earth, or the way that the universe exists according to our current understanding, is that we started off with the Big Bang, and essentially everything that is everything just went from one central area, and it was very, very hot, and everything exploded out very, very quickly, and there was so much stuff, everything that you can touch, feel, imagine, that came from that initial explosion thing, which I find mind-boggling, like how everything can come from something so constant and then suddenly be anyway. That blows my mind a little bit. So I'm not gonna talk about things I don't quite understand. But yeah. So that means that as these things exploded out, there was big chunks, there were small chunks, but the dust particles that were strewn across space have their own little teeny tiny gravitational fields. Everything does. You do, I do, your morning alarm, even though you wish it didn't. They all have their own teeny tiny little gravitational fields, and it's only because Earth is so big that we can feel it all the time, and it impacts us so much. And the moon has one as well, which is why it influences the tides. And all of the planets, everything has its own gravitational field. The sun, everything. So these little tiny particles, they slowly, over the course of billions and billions and billions of years, attracted together with their own little gravitational fields and built on each other. So it became a little ball of particles, and then a bit bigger and a bit bigger and a bit bigger and a bit bigger. And at some point, it got huge, massive, and contained the right amount of chemicals, or chemicals. Everything's made of chemicals. To be able to form into a sun. It generates heat. It's full of oxygen and other stuff. Let me see. Let me Google it. Hydrogen and helium, mainly. There you go. Which burn at astronomical heats. Truly insane. Let me have a look. 15 million degrees Celsius. And that's when, here we go, nuclear fission begins, igniting the core and setting off the next stage of the star's life, according to nationalgeographic.com. Thank you very much. Which is really cool. And the star becomes a star for the next portion, however long that is. No, I have to sign up for National Geographic. Okay, never mind. I think it's billions and billions of years. And then eventually, as with our sun, it will die. It will explode into a supernova and engulf Earth in its heat, which is a cool way to go out, but I imagine that human beings will be far gone by then. Long gone by then. And so then as it explodes, it goes out, and then all of the things that are left over come back together and form something super, super dense, which I believe is called a neutron star. Or in certain circumstances it does, if the star was really, really big to begin with, like a red giant or something like that. You can have like white dwarves as well, but I'm not entirely sure what those consist of, because I haven't looked at that kind of thing in a while. yeah, and neutron stars are really incredible because they are so dense. It's insane. They're really really heavy because all the matter is packed in so tightly. It's everything, like it's all sorts of things. It's not just like stone and rock or helium and gas. It's a bunch of things, and everything's packed in so tightly. I think I can't remember how big they are. They're not too big. Let me see. Okay, so they tend to be having a radius of between 8.2 and 8.9 miles, which is 13.25 and 14.25 kilometers. And that's the radius, that's not the width. The width would be twice that, so 16 to 18 miles and 27 to 29 kilometers-ish wide, which is really, really small on the scale of things. Really, really, really small. It's like a small town, right? However, I've heard that if you were to fill a little thimble or like maybe a pea size with the matter of a neutron star, it would weigh as much as a mountain. That's insane. That's insane. Absolutely incredible. Really, really cool. Really, really cool. And then I don't actually know what happens after that point. That's the end of my knowledge. But there's a bunch of things that get shot out during the supernovas, and then those particles then go out and reform and turn into other things, and that happens to everything in the universe. Eventually, we will become the stuff that burns in stars, and we already have been, because the way that everything works and is conjoined together and everything. Yeah, it's crazy, and that is why I really like the pet name Stardust, because it's cute and nerdy as hell. So yeah, where was I? After we cut off on that star tangent, I was talking about we got the moon. Yeah, moon. Sure, let's go for moon. I don't remember. So we've got the moon, which is really cool, made of all sorts of things. And then after that, we have the other planets. We have satellites around us, but I'm only going to talk about one particular satellite today that I know of. Well, it's not a satellite anymore. A probe, I suppose. Man-made object. So, excuse me. There's the standard solar system, right? We have the Sun, we have Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. And if we were still counting Pluto, then Pluto. I'm going to give it an honorable mention. And my little tidbit for fact is that most people think that Mars is our closest relative, and technically it is in its path around the sun, right? It's slightly further out than we are, you know. It's not too far out, right? We've sent probes there and things like that, although it has taken a long time. And it's not actually true for most of the year, because of the way that the orbits work. So Mars has a very similar orbit to us, which means that when it's not close to us, it takes a really long time for the planets to kind of get back together. Imagine you're seeing another person on the other end of the room, and there's a big thing in the way in the middle, and you can't get to them straight through them. You have to go around the big thing. Let's say it's a big ball, right? But you know they're on the other side, and you both walk the same way, just at ever so slightly different speeds, or like the same clockwise, counterclockwise. That's what I mean. Oops, sorry. Then it's going to take you forever to catch up with one another. However, Mercury has a completely different orbital speed and time to ourselves, and so we're actually really close to Mercury a lot of the time because it takes so little time for Mercury to get around the sun, and it just ends up meaning that Mercury is closer to us more often than Mars is, which I find quite entertaining as well. Yeah, something I also read recently is that the main issue with inhabiting Mars at the moment is that it has on its surface something like 30 times the lethal dose of radiation. So we're going to have to figure that one out first, I believe, before we even think about oxygen. It's going to be quite a challenge, I think. Also, it's going to be really cold, and we can't have blankets if the blankets are frozen. Anyway, that's honestly some of the stuff I come out with. So then we have so Mercury's very hot, Venus is very hot, Earth's basically perfect for us and like life and planet development as an ecosystem. And then Mars is a bit too cold, and then Jupiter is the gas giant, so it's going to be difficult to grow things on that. And something okay, this is ever so slightly space related, but really cool. So Saturn's rings, right? They're, I think, like 130, 150 million years old, right? Our planet has had trees, let me see, for 400 million years. So trees are older than the rings of Saturn by nearly 3 times, 2.5 times, depending on which end of the scale I am. Hang on. And then sharks have been around for 450 million years, which is another like what, 10 and a bit % on trees in the same kind of forms. So it goes sharks, wait a bit, trees, wait a bit, actually quite a long time, and then the rings of Saturn. I'm doing hand motions like my brain's exploding. You can't see it, but that's what I'm doing. It's insane. It is insane. Okay. Yes, and there's is it Jupiter's moons? One of Jupiter's moons, Titan, I think. Titan. Saturn's moons. Yes, here we go. So, it's the only moon known to have a dense atmosphere. It's one of like the 60-something moons that Saturn has. And the only moon or planet other than Earth on which there's clear evidence of stable bodies of surface liquid which have been found. And when I last Googled this, we didn't know what the liquid was. It could have been water, it could have been soup, you know? Nice chunky vegetable soup. Equally likely. It could have been rivers of gold, it could be, you know, liquid nitrogen. Well, probably. Well, yeah, it could be liquid nitrogen, actually. Maybe? I don't know. I don't know if it's that cold, actually. But it's yeah, that's cool. I find that cool. And something I wanted to mention earlier. This is going to be just a lot of tangents. I'm going to be honest. Is that if you imagine the age of the universe, right? So from the Big Bang to right now, as you're listening to this, the universe, let's say, put it on a 24-hour clock, right? In the scale of things, just to put it into perspective, I believe that humans have only been around for about 3 seconds. It's something like that. In like a good 24 hours, we've only been around the last 3 seconds, which is also mind-boggling. So now we're going to get on to kind of like the size of our solar system, right? So there is lots of planets. Well, 8 in our solar system that we're counting. Sorry, Pluto, at the moment. And if we take into consideration how far is the moon from Earth, it's 384,400 kilometers, which is some amount of miles. Divided by 1.6. Sorry, guys. I'm not doing that off the top of my head, gonna be honest. And then the distance from the Sun to the Earth is 147 million kilometers. So that's a good, let's say that's 1.3, or 0.3, sorry. That's like 450 times as far. So when I said Earth's in comparison to the moon's earlier, I think I said, 38? Then times that by 450. And that's how far the Sun is away. That's pretty far. That is pretty far. Crikey. 147.68 million kilometers. About 150 million kilometers. Right? And in that distance, it takes light, which is the fastest thing that we're aware of, 8 minutes to get from the Sun to the Earth, right? 8 minutes, which is mind-bogglingly fast. Really, really fast. And that is counted as 1 AU, I believe, is what it's called. 1 AU. 1 astronomical unit. Which I quite enjoy. That's the distance from the Sun to the Earth. Okay. I'm forming that in my head, right? And the distance from the Sun to, let's say, Neptune is 4.47 billion kilometers, or let me see if I can get it in AU. Okay, from the sun... Oh, wait. No. From Earth to Neptune is 29.09 AU. So that's 29 times as far. So let's say that's 30 times, because if we're going from the sun to Earth, then from Earth to Neptune, that's going to be about 30.09, which is a lot. That's 30 times like 450 Earths distance, or 38. And this is only the beginning. All right, if you're struggling at the moment, don't worry. So am I. But prepare for your mind to be continually boggled. All right. Which, according to Google, is 0.000473 light years, which is a light year is how far light can travel given one Earth year, right? And it gets from the sun to here in 8 minutes. So it's really far. It's really, really far. Really, 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 really far. Right? Really far. However, back in 1970 something, let me go find it. I was looking at a website earlier which was really good. There is a probe, yeah, space probe. Here we go. Launched by NASA on the 5th of September, 1977. Okay? Nearly 45 years ago, is it? Yeah, nearly 45 years ago. Right? And they sent it out to go have a look at Jupiter and Neptune, I think. Hang on. Let me go find it. Is this the website? Yeah, I found the website. Here we go. Okay, here we go. So yeah, it was launched on the 5th of September 1977 at 1 second, 56 minutes past 12 in the afternoon. It weighs 1,500 pounds, nearly 1,600, which is 722-ish kilograms, which is relatively small, I would say, for a satellite. Oh, here we go. So it was launched 44 years, 2 months, 19 days, 5 hours, and 58 minutes and 28 seconds, according to when I'm recording this, ago, right? So it's going out quite far, right? It Jupiter and Saturn, that's where I was looking at, right? So it takes a year and a half to get to Jupiter, right? It flies by Jupiter on the 5th of March, 1979. And then another nearly year and a half passes, or maybe a little bit over a year and a half, 12th of November, 1980. Oh no. Yeah, nearly. It goes and flies by Saturn, right? That's crazy, because Saturn's far away, right? Let's see. Earth to Saturn distance in AU, because that's a nice little unit for us. 7 AU, 7 astronomical units, right? 1.2 billion kilometers. So that's quite far away. It's quite far away. And then, just under 8 years later, February the 17th, 1998, it became the most distant human-made object after it overtook the Pioneer 10, which I have no idea was anything about that at the moment. But at the moment, we're focusing on this probe, the Voyager 1, right? Okay. So then, on the 1st of January 1990, they were like, hey, we can still communicate with this thing. We can still get pictures, things like that. they were like, hey, let's send out on an interstellar mission, right? Interstellar is crazy big, right? And on the 16th of August 2006, right? This thing's traveling fast. Really fast. Alright? Have a guess how fast you think. And I'm gonna boggle your mind, alright? It is currently traveling. Let me go find it. Let me go find the exact speed. It is currently traveling at 37,923 miles per hour, or 61,032 kilometers per hour. That's insane. That's insane. That's like, what? Nearly 15 a second? That's insane. That's really, really fast. Really, 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 really fast. And so, on August the 16th, 2006, it reached 100 astronomical units AU from Earth, I believe, or either from the Sun. Either way, huge distance away, right? Huge distance away. And it's still being affected by the Sun's gravity. Again, Sun's huge, so it's got lots of gravity. And 6 years later, 2012, in August, it finally enters interstellar space. And it's still going right now. It's still zooming on ahead at those astronomical speeds. And that is barely scratching the surface of our solar system, right? And then we start thinking about, our galaxy. Oh. Okay, hang on. Okay. So, we've got that idea in our head, right? So space is really, really big. This satellite that's been traveling for 44 and a bit years at those immense speeds is like just kind of coming to the edge of the sun's gravity at the moment. And we know that there's other stars, we see them in the sky at night, right? There's quite a few of them. And each one has their own little solar system, or is very likely to have their own little solar system. And we've all heard of the Milky Way, yeah? Which is our galaxy. And this blows my mind. There is 100,000 million stars in the Milky Way, our galaxy. 100,000 million. 100,000 million, right? Which, I suppose if you're coming from America, would be classed as 100 billion, right? 100 billion. Stars in our galaxy. Each with their own kind of thing, with their own astronomical... we're getting big now. Like... I'm doing the hand motion again, alright? It's crazy. It's crazy. And then we know about Andromeda, right? Which is our it's a galaxy that's going to collide with the Milky Way at some point, like billions of years in the future. We're not going to be around to see it, but it's going to happen at some point. They're moving towards each other, and there's going to be like some things that crash into each other, I imagine, because gravity's a thing, but most likely the things are so far apart that it's not going to make a difference. Which is also really crazy. There'll probably be like an exchange, there'll be some things, there'll be momentum here, momentum there. Who knows what will happen when it comes out of it, right? They might like swirl around each other and go and become one bigger galaxy, or they might like... Anyway, I could talk for ages about what could happen. But there's 100,000 million or 100 billion stars in our galaxy, and that's just one, right? And so, in what we can see in the sky at the moment with our big telescopes, is that there are 125 billion galaxies. I don't know who counted all those, but that's quite a few that we can see. Right? That we can see. So, just to reiterate, right? Okay, so we've got Earth, pretty big. Yeah, we're familiar with Earth. We've been on it for a while, right? And between the Earth and the Moon, let me see how many. Uh, 30 Earth-sized planets. There we go. 38 was a bit off, right? 30 Earth-sized planets could fit between Earth and the Moon. So we've got 30 planets there. And then the Earth to the Sun is... What did I say? Oh, a bunch times that. I mean, it doesn't really matter. It's going to get ridiculous anyway. Loads times that. Like, did I say 150 times? Something like that. Which is a lot. Big distance, right? Somewhat graspable. Because we know the sun, we know the moon. Distance away. Okay, got that. Kind of know how big Earth is. And the distance between us and the sun is 1 astronomical unit. And there's... How many did I say for the Voyager? A bunch. 23 billion kilometers. 150 AU. 150 AU at the moment, right? 150 AU. It moves at about 3.6 AU per year. Okay. 150 times the 150 times the 30 Earths, alright. And then there's 100,000 million of those. And they don't have to even be close, right? They could be so far apart from each other. That's just galaxies on their own. Or little solar systems on their own. They could be vastly far apart. In fact, how wide is the Milky Way? Here we go. Okay. Oh man. Okay. So it says here that the diameter of the Milky Way is 105,700 light years. Light years. Which is... Oh man. 1 light year is 63,000-ish astronomical units, AUs. Oh man. Okay. And then we think there's about 125 billion of those, which is like 1.25 times 10 to the power of 11, right? And that's just what we can see. I heard, or I think I read somewhere, right, that our perception of the universe at the moment is about, if you imagine, trying to put this into terms that I can visualize, right? About as big as the bulb, or about as big as a bulb, right? I'm Googling here in a second. Okay, about as big as a bulb. And what we think, based on like the velocity of things moving from the Big Bang, right? We think that things could be moving out at a certain rate. There could be things moving faster than the speed of light, which is another tangent fact, which we will never ever know about because it's moving away from us faster than the light is moving towards us. So, big explosion, big brain explosion, right? Which is insane. We think that we can see about as much as that little light bulb, that little glass shape, if the what we believe to be the size of the universe was as big as Pluto. Pluto. And this is why I'm giving it honorable mentions. Now, Pluto is not as big as our moon, right? But it is still really big. It is 2,376.6 kilometers. Right? Let me just see how many bulbs could fit into Pluto. Alright, that doesn't seem like a question anybody's asked before, so there's not a particular answer, but that's a lot of bulbs. That's a tiny fraction. And yet we know so much about that fraction. We know that there's so much stuff. It's so massive and big and huge that it makes you feel really, really small. And you know that can be comforting and also kind of fear-inducing, existential dread, perhaps. But wow, you've got to be amazed at that, right? That is so cool. That is so cool. And our communication, our radio signals. If you imagine the Milky Way again, you know, we've probably come across something like that before, right? Milky Way. It's just like a tiny little circle on the Milky Way. I don't know how far out it goes. How far do our radio signals reach? Traveled up to 116 light years away, which is really, really cool. Really, 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 really cool. That's far distance, right? We said that 1 light year was like 63,000 AU, so 116 times that. That's really far, really, really far. But on the scale of things, it's nothing. It's nothing. And there's so much more to learn, and that is incredible. That's so cool. That's so cool. You might have picked up by now that I'm a little bit interested in this kind of stuff. I was considering doing astrophysics at university, and I may still do something to do with that at some point, but that's so cool. That's so cool. Really, really, really cool. Maybe I can do a master's or something. That'd be cool. Anyway. Space is big, y'all. It's real big. It's real, real big. I think I can put this Voyager 1 webpage into the description somewhere. It's from NASA, solarsystem.nasa.gov, and it just tells you all about the Voyager 1, and it even has like a little interactive visualization, I suppose, that you can get a bunch of information from. Don't bother trying to zoom out to get a sense of scale, because as we've just discussed, you might be scrolling for a hell of a long time. Oh man, it's I find this kind of thing so cool, and I hope that you did too, if you're still listening or asleep. Maybe I've kind of given you some facts to learn about in a weird way, just kind of inputting it while you're sleeping. Okay, I'll finish off with just a couple of facts from this webpage. It says that, wait, okay, what I've just remembered, right? So, there is a photograph that the Voyager 1 has taken. It turned around, like it rotated around to look back where it came from. And you can get this photograph up on the internet. Oh, I've just thought of another. Oh, okay. As long as I keep this under an hour, it'll be fine. So there's the photograph of the Voyager 1 as it's turned around. It's still traveling away from us, but it's like turned its little camera head towards us and taken a picture. And you can see all of these things, and it all looks like a little, bunch of colors and images and things like that. But there is one tiny little pixel of what looks like dust, right? And that's Earth. That's Earth. Everything that we know, everything that we have ever thought about, everything that we've ever made a plan about, everyone that we've ever known, or will know, or have read about, was on that tiny little speck. Tiny little speck. I'm doing the motions again. Blowing my mind. And while I'm on the subject of photos, before I get to the final facts, there is, the hottest thing in the universe, which I think is a really, really cool fact, apart from all of you lovely people, is something called a quasar, right? You'd think it was like a supernova or something like that, but it's not. It's something called a quasar, which is a really, really nerdy word, and I love it. And for the Hubble telescope, Hubble Space Telescope, its 10,000th photograph, it took a picture of two things. Somehow, it got lucky enough to take a picture of a supernova and a quasar at the same time, right? And the supernova is super bright, right? Super bright. You can see, oh, damn, that's a supernova. That is a star exploding, right? And we also see a quasar. Now, the quasar is... Oh, wait, is it the hottest thing or the brightest thing? One or the other. Might be both. The quasar is about 100 times further away from us than the satellite was, or the supernova was. And the quasar was brighter on the image than a supernova, and it was 100 times further away than us. It might not be 100, but it was really far away. I mean, I'm remembering this off the top of my head. And what a quasar is, I should explain what it is when there's a black hole, which is just, matter that's another thing that stars can be. Anyway, when they die in the neutron stars, because those are really dense, if they get even more dense than that, then they become a black hole, which is just something that's so dense, it has so much gravity that it just goes and sucks everything in around it, right? Including light, which is crazy. So yeah, it sucks things in, and there's a lot of things in space, right? And they're really far apart, but what this black hole does is it sucks all the things in, and they don't just go straight in, right? There's like a little spinning cycle, and as they get closer and closer to the black hole itself, they get squished closer and closer together, right? But everything's trying to get on top of each other because the gravity of this black hole is just so immense that they're all crushing each other and scraping against each other, and the friction, that little kind of friction. Sorry about that. A friction is generating so much heat and light that it can be seen from astronomical distances away. And that is the either hottest or brightest, or maybe both, thing in the universe that we know about so far. Which is also really cool. It's really, really cool. Okay. Yeah. Voyager. Right, Voyager 1. Alright, so okay, so Voyager 1, bearing in mind this was launched in 1977, so it's still got the technology from 1977. There's not been anybody up there to go and catch up and upgrade its software. it doesn't have the weekly updates. It carries a copy of something called the Golden Record, which is like a message from humanity to the cosmos. And it includes greetings in 55 languages, pictures of people and places on Earth, and music. It says here, ranging from Beethoven to Chuck Berry's Johnny B. Good. And I think that's fantastic. Oh, this is so cool. Such cool stuff. I really enjoy learning about this kind of thing and hearing about it. Oh, and I hope you've enjoyed listening to it, at least a little. Congratulations if you got to the end. And if not, then I hope that you managed to at least glean a little bit from it. And I hope you're doing okay with whatever you're going through, whatever you're doing, whatever you're up to, your plans, anything like that. So, yeah. See you later.